There is a strange and haunting truth about our species that most people never hear. We were not the only humans who once walked the earth, and the other kind, the ones who were powerful, cold, adapted, and astonishingly intelligent, never truly vanished. They are still here, inside us, carried in our blood like a whisper from a forgotten world. Neanderthals disappeared 40,000 years ago, yet their genes continue to live through us, passed down from a time when two different kinds of humans stood face to face in the frozen landscapes of Ice Age Europe. Imagine that moment. Snow whipping across an open plain, firelight flickering against heavy breathing, two species, separated for 500,000 years, staring at each other with curiosity, fear, and something far more profound. One was lighter, faster, with a voice full of tones and colors. The other was stocky, barrel-chested, and strong enough to break bone with a single twist. And somehow, instead of destroying one another, our ancestors crossed a boundary that no animal on Earth had crossed before. They mixed. They shared skills, warmth, stories, bodies, and eventually children. And in doing so, they shaped the future of every human alive today. When our ancestors finally stepped out of Africa and pushed into the colder edges of Europe, they were not alone. Their fires burned small and bright under the endless night sky, but somewhere beyond the tree line, another fire was burning too, and around that fire stood a different kind of human, stronger, broader, older. These were Neanderthals, shaped not by warm savannas but by the brutal winters of Eurasia. Their bodies had adapted to cold, the way stone adapts to pressure. Their chests were deep and powerful like the bellies of drums, their bones thick and heavy, built to survive a world filled with ice, predators, and sudden hunger. The two species did not look or sound the same. Our ancestors moved with a quick, almost restless energy, their limbs longer, their voices filled with light tones and agile sounds. Neanderthals spoke too, but their voices carried a different resonance, a deeper timbre shaped by broad faces and a large resonating chamber. Their language, whatever it was, would have sounded so alien that no human alive today could ever reproduce it. And just as our words were foreign to them, their social signals were foreign to us. Neanderthals used their heavy brows as part of their communication, lifting and tightening them in ways that modern humans cannot fully imitate. What looked like a threat to us might have been a greeting to them, and what looked like calm to them might have been our sign of fear. The chance for misunderstanding was enormous, yet something remarkable happened. Instead of panic or violence, there was a long moment of watching and learning. Two species circled each other, not like predators, but like cautious reflections. Neanderthals studied the speed and precision of the newcomers. Humans studied the raw power and silence of their ancient cousins. The frozen world forced them to pay attention. In an age of mammoths, cave lions, and deadly winters, survival depended on understanding every creature you met, especially the ones that looked unsettlingly like yourself. Slowly, through observation and imitation, the walls between them began to thin. A gesture copied here, a tool technique imitated there. Something new had begun. Not friendship, not yet, but the first fragile bridge between two forms of humanity. As the first fragile bridge formed between the two species, a different kind of exchange began to unfold, one that was far more intimate and far more revealing. When humans and Neanderthals watched each other closely enough to imitate gestures and copy tool techniques, they also came close enough to share breath, food, and eventually the microscopic companions that live within every human mouth. This is where archaeology unexpectedly gives us one of the most human clues in the entire story. In a cave in northern Spain, a researcher named Laura Wyrick found a microorganism inside a Neanderthal tooth. That tiny organism, Methanobrevibacter oralis, is the same one found in your mouth today. But not every Neanderthal carried it, and the simplest explanation for its sudden appearance is one most people never imagine when they think about the Ice Age. It suggests that a Neanderthal and a modern human once touched mouths. Whether it happened through the sharing of chewed food, through a cultural gesture, or through a moment of closeness that we would recognize as a kiss, the result was the same. Two species crossing an invisible biological threshold. But microbes were only the beginning. When two populations live near each other, they do not just share firelight, they share sickness, They share immunity. They share weakness. Humans carried viruses from Africa, viruses that Neanderthals had never encountered. Some of these, like ancient strains of herpes or intestinal parasites, may have passed quietly into Neanderthal groups. At the same time, Neanderthals carried their own biological signatures, including a variant of human papillomavirus known as HPV-16 This strain, found mostly outside Africa today, appears to have entered the human lineage precisely when the two species first encountered each other. The timing is too perfect to ignore. And beneath all of this was a deeper social pattern described by anthropologist Ludovic Slimak. Across human history, when two isolated groups with different languages meet, they often exchange women, not as a violent act, but as a strategy for survival. Exchanging women builds alliances, blends traditions, and creates clans that can survive famine, cold, or conflict. It is a universal pattern found in many ancient societies, and there is every indication that humans and Neanderthals followed the same rule. Women crossed between camps, families blended, and the biological boundaries that had existed for 500,000 years quietly began to soften. As humans and Neanderthals continued to build fragile connections, their lives became entwined in the most profound way any two species can experience. These encounters were not simply alliances or exchanges of knowledge. They eventually resulted in children, the living proof that two different kinds of humans could cross one of nature's deepest boundaries. But this union, as remarkable as it was, carried with it a quiet tragedy written directly into the biology of both species. Genetic research shows that male humans and female Neanderthals could produce offspring who survived and continued their lineage. But the opposite pairing, a male Neanderthal and a female human, rarely resulted in children who lived. For a long time this seemed like a mystery, but new insights from ancient DNA offer a clearer picture. Neanderthal babies were physically large, shaped by a species built for power and endurance. Their mothers had broad hips and robust bodies, adapted for delivering such infants. Human mothers did not. A child with Neanderthal paternal genes may simply have been too large or genetically mismatched to survive pregnancy or birth. It is a biological conflict seen even in animals today, where hybrids often fail because the bodies of the parents evolved on separate paths for too long. Another factor lies deep within our cells. Neanderthal males carried a Y chromosome that functioned alongside Neanderthal mitochondrial DNA, the energy systems passed down only by mothers. But when that Y chromosome interacted with the mitochondria of a human female, problems may have emerged: metabolic issues, developmental failures, or immune conflicts that prevented the child from surviving. It was not a matter of choice or violence. It was a quiet incompatibility, the kind nature resolves without warning. And yet, the unions that did succeed left a lasting imprint. Humans and Neanderthals appear to have been largely monogamous, something suggested by genetics and by the absence of anatomical traits associated with intense mate competition. Their families were small, close-knit, and built on cooperation rather than dominance. So when a human male and a Neanderthal female formed a partnership, it was likely stable, trusted, and woven into the social fabric of their groups. But this stability only served to highlight the deeper imbalance. One side of the union could create surviving children, the other could not. And over thousands of years, this quiet asymmetry began shaping not only the future of our species, but the fate of theirs. The children who survived between the two species carried more than a shared face or a mixture of features. They carried the combined histories of two worlds, and some of the gifts they inherited from their Neanderthal ancestors were powerful advantages. When humans left Africa, they entered a land filled with new pathogens and piercing cold. Neanderthals had already survived these challenges for hundreds of thousands of years. They had immune genes, called HLA genes, that could recognize European and Asian diseases far better than the immune systems of early humans. They also carried genes that shaped taller noses, allowing icy air to be warmed and moistened before reaching the lungs. Other Neanderthal genes helped regulate fat storage, boosted heat production in brown fat, and even influenced skin tone to better absorb sunlight in cold, dark regions. These were the silent gifts that helped humans take root in a world that once belonged almost entirely to Neanderthals. But not every inheritance was a blessing. Some Neanderthal genes make modern immune systems too aggressive, triggering autoimmune disorders such as arthritis or Graves' disease. Others heighten sensitivity to pain or increase the risk of certain hand disorders like Dupuytren disease. Most striking of all, a major genetic risk factor for severe responses to a recent viral outbreak matches perfectly with the Neanderthal genome. The legacy of their immune system, once powerful in the Ice Age, can sometimes become dangerous in the modern world. And yet, the most fascinating clues come from the ancient bones of real hybrids. In Portugal, the remains of a child known as the Lapido child show a blend of both species in the shape of its legs and skull. In Romania, two individuals called OASE-1 and OASE-2 carry unusually high percentages of Neanderthal DNA, up to 9%, along with facial and jaw traits that echo their ancient relatives. Even more surprising, a bone fragment found in Siberia belonged to a young girl whose mother was Denisovan and whose father was Neanderthal, proving that these human species mixed far more often than once believed. But all of these discoveries point toward a slow and uneven union, not a true merging of species. Human populations were larger, more connected, and more flexible. Neanderthal groups were small, scattered, and burdened by the biological imbalance described earlier. As women moved between groups and as children inherited genes unevenly, Neanderthal populations became thinner, stretched across a land growing colder and harsher. In the end, their extinction was not a sudden battle or a single catastrophe. It was a long erosion, a quiet fading, a species slowly overwhelmed by climate, by isolation, by illness, and by the simple mathematics of survival. And yet, they did not vanish completely. A small part of them continued forward, carried in the people who would someday inherit the earth. In the end, the story of Neanderthals is not a tale of monsters or rivals. It is the story of another kind of human, one who weathered storms we can barely imagine and carved out a life in a world of ice long before our species arrived. They were powerful, intelligent, emotional, and deeply social. They buried their dead, tended to their wounded, and left marks of color and craftsmanship on the caves they called home. And when our ancestors finally reached their lands, the two species did something extraordinary. They reached toward each other rather than away. Their disappearance was not a defeat. It was a transformation. Climate shifted, populations changed. Small groups scattered too thinly across too harsh a world began to fade. But their story did not end where their bones were buried. It continued quietly inside the bodies of the children they helped create. Children whose descendants would one day circle the entire planet. If you carry ancestry from outside Africa, you carry between 1 and 4% of their genetic legacy. A small percentage, yet enough to remind us that they are still here. They see the world through our eyes. They breathe through our lungs. And every time we step out into the cold and feel our bodies adjust, a tiny part of that adaptation comes from them. So the question is not why they vanished. The question is how much of them still lives on in us, guiding us, shaping us, and reminding us that humanity has never been just one species, but a family whose branches once tangled together in the frost of an ancient world.